Okay. Okay. I think from this class is quite good, and also from the homework. Maybe you guys need to always remember the process when you do the homework or do the quiz. Okay. So as always, welcome all fellow crewmates of Calculus crewmates. So today we're gonna have uh, some practice. Maybe, yeah, I just prepare 5 numbers and we can discuss. So I will give you some times to prepare your pen, your paper, your calculator, maybe, and we can start after that. I'll give you some time to prepare. Please prepare the pen and prepare the pen, the calculator, and all things necessary. Oh yeah. By the way, the attendance I will give you later. So let's just practice for now. You guys can scan it here. Okay. Very good. Very good. And let's have some practice today. Oh yeah. Uh, okay, maybe later. I really hope you can use your student ID number for the name or your English name. It's okay, or your Chinese name. It's okay, as long as I can recognize you. Okay. This Menti thing is really good. Does anyone have the problem when scan the QR code? I think no, right? I think we need one more student. One, two. Okay. Think one more student, not yet enter. Okay. Okay. I think everybody already enter. So we can start now. Maybe it's quite long, but I give you enough time to do it. So, Chayo, guys, later if you have any problem, can discuss it. It's 2 minutes. I believe this question is about the chain rule. It's about the chain rule. Okay, 1 minute to go. Chain rule first. Then don't forget it's perpendicular, guys. It's not parallel. Remember the difference between perpendicular, parallel. 10 seconds to go. Okay. Thumbs up. Okay. Very nice. Very nice. Very nice. Good, 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 good. Let's see. Oh, okay, okay, okay. Very good, very good, very good. Okay, next. Number two. Oh, five. This one is about implicit differentiation. Chapter 3.5. No, it's already, one guy's already finished. Very good, very good. So there's no problem with number one. I believe it's very good. It's implicit differentiation. I believe it's quite long. But I hope you guys can finish it. Still 2 minutes. Be careful with the sign of every answer. The first option is minus and minus. The second option is minus and plus. The third option is plus and plus. Okay, already 6 people. 7 people. 8. 9. Very good, very good. 1 minute to go. Six more people. Nice, nice. 30 minutes to go. Okay, good, good, good. Two more people. One more people. Very good. Nice. Let's see. Is it correct? Okay. Okay. Very good. Very good. Some of you still have the problem. Maybe we can discuss it later. But now just continue first. The third one. Let's see. Leaderboard. Oh, very nice. Very nice. Okay. Sayo for all of you guys. Next. Number three. Well, some of you still have some problem with number two. Ah, I believe this is easy money because I just realized Professor Iman have discussed about it in the class. But I just want to give you some difficulties. Five people, six, good, good. Seven. I believe Professor Iman already discussed about this question last week. 10 seconds. Go, go, guys, go. Six more people. Five, four. Okay, let's see. Okay. Okay, we will discuss about this number. Ah, the next two number is quite important. So I will give you really long time for this one. Let's see. Yes. This one is for, hey, wait. I think it's very, yeah, try your best to do it. It's 2 minutes. It's about related rates. Oh, okay, very good. Four people already answered. Forget to write the triangle first. Nice, nice. 5 more people. No, 2 more people. Eh, 3 more people. Ah, very nice. Let's see. Okay. Is it too fast maybe? So you don't have more time? Okay, we will discuss about this. This one is about related traits. Okay, last one. It's pretty easy. Oh, you have an answer. It's okay, it's okay. Okay. Very good. Last question. It's about linearization. I think it's pretty easy, so I think 1 minute is enough. As long as you remember the function, it's pretty easy. Go, go. For people. Go, 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 go. Ah. Oh, 13 It's true? Okay, say one. Okay. So I guess we still have some problems with the uh, related range and related lengths, and the last one, the approximation. Okay, congratulations, Scarlett. Thank you very much, guys, for joining the practice today. Maybe I give you this one first. You can fill the attendance, and after this, we can discuss about some of the number. Don't forget to be honest. And when you feel it, if you have some problem with certain topic, just write it. Maybe the related traits or the the last chapter, the linearization traits. Okay, okay, okay. Some of you so far so good. The related trait. Okay. The limits. The time limits are too short. Oh, okay, okay. The time limits. The topic of third question. Don't remember what's the name. Oh, okay. The third question. Soon. Okay. Thank you very much for filling the attendance. Okay. I'm sorry if the time is very short, especially I believe for number 4. And I think that could be the first that we need to discuss today. Number 4. Okay, linear approximation and related traits. So we can discuss about the last two questions because I believe that's the most big problem happens there. Okay. So the question number 4 is this one. Number 18. The spotlight on the ground shines on a wall 12 uh, meters away. And if a man 2 meter tall walks from the spotlight towards the building at a speed of 1.6 meter per second, how fast is the length of his shadow on the building decreasing when he is 4 meter from the building? Okay. First and foremost, I believe Professor Iman always said it too. Make the uh, drawing first to make sure that you understand how it works. So number 18, remember? Yeah. The spotlight on the ground shines on the wall. So there's something spotlight here. And then it's shines on a wall, which is this is the wall, 2 meters away from here to here. So this one will be like this. Sorry for my bad drawing. And this one will be 12. And if a man tall, 2 meters tall, say around here, walks from the spotlight towards, so he go to the wall, the building at the speed of 1.6 meter per second, how fast is the length of his shadow on the building decreasing when he is 4 meter from the building? So when you draw here, it becomes like triangle. And as we know, this is 2, this is 12, and let's assume this part is x. So this one is 2 minus x. And the height of the wall is y. Okay? Because the man here, the 2 meters man, go towards the wall, let's go on the right side, right? So it's become positive. And we know as he get closer and get closer to the wall, his or her shadow will decrease, which is will be minus. and we want to know how fast the decreasing of his or her shadow in the wall. So let me write the important variable that already given. So we know that this man walked with speed 1.6 meter per second. So dx over dt is 1.6 meter per second. Okay, because it goes in the x-axis, right? Go there, and then it becomes 1.6. Let's go to here, it becomes 1.6 meter per second. And by the similar triangles, we know that uh, y over 12 equals to 2 over x. Y equals to 2 over x. Okay, and then you got y equals to 24 over x. And from here, you derive all the sides. So you got d over dt of y equals to d over dt of 24x. So it becomes dy over dt equals to minus 24x squared dx dt. Remember? To 24x power minus 1, and then you move it. Yeah, you know how to derive it, right? Since our question, we want to know the speed of the shadow decreasing, which is dy over dt, which is this one. We just can substitute the number that we already know. Minus 24x squared times 1.6. Okay. And now, how about the x? We know from the question, he says like, how fast is the length of his shadow on the building decreasing when he is 4 meters from the building? 4 meters from the building, which means 12 minus x equals to 4. It means that the x equals to 8. And then we substitute inside dy over dt minus 24 8 squared times 1.6 equals to 4 over 64 times 1.6, and you got minus 0.6 meter per second. And since it's minus, so it's true that the shadow is decreasing. So this is the answer. So how fast is the length of a shadow on the building decreasing? Decreasing, and it's proven here that it's minus. When it's 4 meters from the building, the answer is it's decreasing at the speed of 0.6 meter per second. Okay. Is there any question for the question number 4? So remember, guys, this kind of topic, the related traits, especially, we really need to use our imagination to make sure we draw the figure first, and then we see how it works, and then we use every knowledge that we have about the derivative. Okay? If there's no problem, there's no question, right? This is for, and I'm sorry if for number 4 is very short time that I gave you before. Later, maybe I give the longer time. Okay, for question number 5, it's about the linear approximation. Let's see where's the question come from. I believe this one. Question number 3. Find the linearization of f of linearization Lx of the function at A. So we know that f x to cube root x at A equals 8. Actually, it's pretty easy. As long as you remember what's the function of linearization. So if you remember, the function of the linearization is goes like this: L of x equals to fx. No, sorry, fa. Fa plus the derivative of a times x minus a. The function of the linearization. From here, you have to derive first the function fx. So it's pretty easy, right? F, the derivative of fx equals to 3x squared. Then you put when f equal 8, it will become how much? 2, right? When you put here, right, it's become 2. And when you put the here, It become 1 over 12. So the linearization will become like this: L x fa, so f8 plus the derivative of f8 times x over x minus 8. And you just can substitute it. 2 plus minus, x over x minus 8. So the last result will be x plus 16 per 12, 1 x plus 4 over 3. Okay, this one is for the last number, the linearization. Any question, maybe? So I believe these two is the hardest one, and I will report your problem to Professor Iman. Maybe he will review chapter 3.9 and 3.10 before your quiz letter, so you really have a good mm, concept and good understanding, especially for this chapter. And I believe 3.9 and 3.10 is quite hard. Okay, any question maybe? Mm, oh, I forgot. Oh, there's some of you that asked question about number 3. The topic of question number 3 is actually about the derivative of logarithmic and inverse trigonometric functions. Okay. Believe there's no problem. Maybe just a quick review. Yeah, we still have some minutes, right, for you guys to review. And I encourage you that if you have time or you really need to practice more, you can contact me and try to find this book. Or if you want, maybe I can give you two. You just can email me and I'll give you the PDF of this book so you can practice more. And maybe I will later I will discuss with Professor Iman when exactly the time that he will give you the quiz, and maybe I can give you some small homework maybe, but just maybe just be ready and see in the Moodle. And maybe I want to review some of the important function that maybe you need to remember from section 3.6. It's about the derivative of logarithmic and inverse trigonometric. functions. The first important function of derivative from this section is this one, d over dx log bx is equal to 1 over x ln b. This is the first one. And the second one is this, d over dx of ln x equals to 1 over x. And for this topic, another important is this one. The inverse sine is this one. The inverse cos is this one, and the inverse tan is this one. I really encourage you to have this book, so you can have how they derive this formula. But at least at the quiz later, you need to remember some of the important formula that will be given in the quiz. Okay. I think the implicit differentiation chain rule, or maybe last minute. Maybe. And don't forget about the product and quotient rule. At first, you guys have some problem, especially with the homework. But after sometimes you already understand. So it's very, very good. Okay. Yeah, I think everyone already feel the attendance too. So I think that's just for today. I hope our discussion for number 4 and 5 it's clear, because I believe also there's no question from me. Okay, so we just can finish early today, and I hope you can have sometimes to practice more and more. And you have any problem, you can contact me by email. I believe I already gave you my email. So you can contact me in the Moodle, and always check your Google Classroom and your Moodle too. Okay? Is there any question? Last 2 minutes. And if there's no question, you can leave the class. Really, really thank you for joining the class, and really thank you for your time to attend this class. Thank you. Thank you, Ryan. Thank you. Thank you. Thank you, Johan. Thank you very much. And thank you, Vando. And Chayo. Chayo for your quiz letter. Have a nice day. Have a nice day. Have a nice day. Don't forget to wear the jacket. Thank you very much.